Okay, so welcome to module 3 in this user training series here at Pawsey. The topic is an overview of the file systems, and this is module 3 out of 11 of the whole series. So the learning outcomes for this module cover what is actually a file system and how do they look like on Setonix. And I'm also gonna show you how to monitor usage of the various file systems using some shell commands. And have a look for these icons through the session for key callouts. So before we even talk about file systems on Setonix, so what is a file system? I think it's quite important to clarify this between ourselves. So what we mean by that? So a file system is a method that the operating system of a computer uses to manage and store data, typically on storage disks. So this is what a file system is, just the way the operating system handles data in files or objects. In our specific context, especially in this training, we are also implicitly referring to the underlying hardware used to store data. So sometimes we're going to call file system and mention a file system and also refer to what the hardware of that specific file system looks like in terms of features. So, and you will notice that very soon in the next few slides. Just to give you an idea, to refer this concept back to your local laptop or computer workstation, typically in a personal computer, there's only one type of file system and one type of hardware of disk drive. So just to give you names, you might have heard of them or not, but this is what it actually is in typical personal computers. So in Linux, we have typically the X4 file system. On Apple computers, it's called APFS. On Windows, it's called NTFS. There are more than these. These are just examples of popular ones. And then under the hood, the data typically stored in files. For many years, spinning drives were the most popular technology. Now we have solid state drives, which have been become increasingly popular for personal computers. So this is what we are talking about if you were to discuss file systems on a personal computer. But now we need to move back to Setonix, right, to our supercomputer. First of all, because we are so obsessed with performance in a supercomputing center, we can't really have just one type of file system and storage hardware. We need multiple ones. We actually, so Setonix ends up having a range of storage hardware with and a range of file systems which are specialized for different purposes. And just to give you some examples, that hopefully will give you the idea of why we are doing this, why we're keeping this complexity in terms of file systems of how we manage data on a supercomputer. And actually, so this means there are different software technologies, different hardware, but also different policies and rules that we enforce on the various file systems. So some of them are file systems optimized for read and write performance. So this would be very fast in terms of accessing and writing data, but also more expensive because of this performance. Some of them will be optimized just for storing data. So putting that data there that you need to use often. You just need a lot of capacity to store a lot of data. So this is about actually power efficiency to keep the bill low, and also hopefully durability of the drives of the storage hardware. A lot of the file systems on a supercomputer will be optimized for shared use by multiple users, because as we already said, this is what a supercomputer is. It's a shared facility. Many people need to be able to use the facility at once. And some file systems will not be optimized at all. There will be just the cheaper ones available for the purpose. In those cases where we just need a place to store data where performance is not crucial, capacity is not crucial. We just need some space, some cheap space for that. In this module, we're not going to discuss the specifics of the hardware. The key takeaway will be about the various file systems, the various purposes, and policies, rules you need to be aware of, and names as well. Okay, so this is just a summary. We're going to enter into detail for each one of these. We have some general purpose file systems that are needed by all researchers at Pawsey. So we have a working space called Scratch. We have a space to store software called software. We have a place called Acacia to store data, your project data, during the life of your project at Pawsey. And we also have a place just to store little configuration files and settings, which is home. And we're going to go back to this very soon. It's also important to mention that because a significant component of Pawsey funding originally came from radio astronomy, we also, and we have these ongoing collaborations with some quite important radio astronomy research projects across Australia and the world. We also have some dedicated hardware just for radio astronomy researchers that we are hosting here at Pawsey. And yeah, for what regards file systems, the key ones to be aware of are Astro and ASCAP buffer. These are mounted on the Garwala supercomputer, which is also dedicated to radio astronomers. They will be soon mounted on a dedicated data mover node as well. All of this is only accessible by radio astronomy researchers. So the focus of the rest of this module will be about the general purpose file systems for Setonix. So let's start from Scratch, the working space. So Scratch is designed for performant, fast, parallel access of data. Technically, it's called a Lustre parallel file system. The use for Scratch is for it to be a temporary workspace for computational workflows that are in the queue, running, or recently finished on Setonix. It's a temporary space for fast access of data. So that's where the workflow running on the compute node will read and write data. Overall, it has 50 petabytes of capacity over the whole user base. And hence, we need to enforce some quota limits. So there is a hard limit of 2 petabytes per research project and 2 million files per user, and a soft limit, which is half that, which is going to be implemented soon. The location for Scratch is /scratch/project ID/username. So each one of you as a user will have this space available. And you can use the $myscratch environment variable, which points to this path for your default project at Pawsey. It's very important to mention there is a purge policy on the Scratch file system. This is because, as we said, it's very important that this file system can work at the highest performance possible. It's where it's what the compute nodes relies on for writing and reading data. And it's also a shared space. So there is a 30 days policy. Files that have not been used for 30 days will be deleted. So it's important to keep this in mind as you design your computational workflow. There will be, the last module of this training will cover more extensively ways of managing your data outside of Scratch. And there will be some mention actually in the next module as well. Be mindful of the purge policy. It's important that you move out the files from Scratch that you don't need anymore. You just need them to store somewhere else, or delete them if you don't need them anymore. And again, this is one of those cases where it's also about making sure that the infrastructure can be used effectively by all of the users. The second file system is called Acacia. It's actually a new piece of hardware we deployed this year at Pawsey. It is designed for a high availability, large volume data storage. So the focus here is large volume. We want to store a lot of data with read-write access, not at the same performance as Lustre, but also not as bad as other type of more standard file systems. Technically, it's called Ceph object storage here at Pawsey. So this space is designed and suitable for storing data during the life cycle of your project allocation. Every research project at Pawsey gets by default to 1 terabyte of project storage on Acacia, which can be upgraded up to 10 terabytes by motivated request through the help desk support portal. If you need more than that for storing your data at Pawsey, there are dedicated allocations, dedicated application forms that can be used, and which require some sort of more detailed justification for your need. Notably, this is a new technology to Pawsey. It operates and functions in a different way compared to other more traditional file systems such as Scratch. It uses a so-called Astra interface. Data there are called objects rather than files, and they're read-only on Acacia. So there is a lot, say, to discover, a lot to discuss about the Acacia object storage. And then for this reason, there is a dedicated user training module number 11, the last one of this series, about managing data on Acacia. So we're going to talk about this quite extensively in that module. Then we have the software file system. This is a similar technology as Scratch, so it's still a quite fast performant file system, but the idea there is to use it only for storing software you need to use for your workflows. So there is a Pawsey area where Pawsey managed and actually vendor managed software is installed, but there are also areas for the research projects and the users to install the software. There you can also store configuration files for the workflows or job scripts, batch scripts that you need for actually running the workflows. You don't want them to be purged away on Scratch, so you can store those little files on software as well. They're part of the workflow. There are quota limits on software as well. It's 256 gigabytes per project and 100,000 files per user. There is a project-wide level under /software/projects/project ID. And if you further dive in the directory, there are also user-level directories with an additional level with your username. And similar to Scratch, there is an environment variable to access those paths for your default Pawsey project, and the variable is my software. In this case, there is no purge policies. The data can be, the software and configuration files can be kept there for the duration of your project Pawsey. And finally, there is a home file system, which is not designed for performance or large-scale parallel access. So it's kind of a cheaper one compared to the other ones. Technically, it's an NFS file system. So Setonix is based on a Linux operating system, and you typically need a home directory for user accounts on a Linux operating system to work properly. So here we go. This is the cheap home file system. It's actually quite useful. It can be used for storing software configuration files, such as a configuration file for the Bash shell or other types of configuration files for other software. You can use it also for private data, such as the SSH keys we used in the login module for better authentication. That's the place for storing those little configuration files. Keep in mind that by default, the home directory is only visible by the user that owns it. So it's a private space. The quota limits are very small because this file system is designed only for these little files. So 1 gigabyte per user and 10,000 files per user. The directory is just /home/username, and you have two shortcuts to that: the tilde symbol and the home variable. This is a practice for reproducibility of your workflows. We recommend to store your workflow-related settings. To avoid storing your workflow-related settings inside the shell configuration files. This is something that in principle you can do, say setting variables for some programs to run more properly and things like that, or preloading some software to be readily available when you log in. We recommend to store these settings in the actual batch scripts that will execute your jobs instead. This is better both for you, for reproducibility, because you have all of the information on how the workflow is set up and run in the same place, the batch script. It's also good if you need to share it with your collaborators, because everything will be there. There is no hidden magic setup in your home. And it's also good if you need help from Pawsey staff, because as I said, the home directory can only be accessed by you and by no one else. Okay, so we gave you this overview on the various file systems at Pawsey. Now let me show you how, and I also told you that there are some file size and count quotas on Scratch software and home. Let me show you how to monitor your quota usage for those file systems. So so this is just a demo. I'm gonna show you the command. If you're logged into the system, feel free to try it yourself. It's all tracked in the slides and recording anyway for you. So I'm back on the terminal. I'm using the top arrow key of my laptop just to go back to my SSH command, where I'm using the SSH key to log into Setonix. If you don't have the key, you can just use the same command without the flag. Well, actually, for better accessibility for you guys listening, let us just go the easy way. So SSH username at setonix.pawsey.org.au and the password. So let me show you the commands to have a look at your quota usage for the various file systems. So there is a command. There are a couple of different commands that are available. So quota-s is useful for your home space. It gives you the quota values. So the quota is 1 GB, and I'm currently using about 100 megabytes. The file count limit is 10,000, and I'm using 300 right now. So this is for home. So you see that you get to see your current usage and the quotas for reference. Now let's see. Let me just clear the screen. And let's see the command for Scratch and software. So there are a couple of commands available. The easiest one with the simplest interface is called Pawsey account balance. And if you can't remember the full command, you can actually start typing Pawsey and then use your tab key on the keyboard to go for tab completion, which is a feature on typical Linux shells. And the command is Pawsey account balance with a couple of capital letters. This command actually shows stats on your Pawsey project overall on Setonix. Let's set the -s flag that stands for storage, and in that way you get a print at the very end of the usage on Scratch and software for your default project, which in my case is Pawsey 0001, and there is usage and limit, and same here for software usage and limit. Keep in mind, we have a slightly larger limits as Pawsey stuff because we need to install extra software for user support. Your limit would be 256 GB for software. Let me also show you. So this is the one that you're going to use most of the time. But let me show you what this command actually uses under the hood. It is a command that comes with the Luster software stack. Remember that Luster is a technology of both Scratch and software. So the command is LFS, Luster File System quota. Let's add this flag, which is human readable quantities. Let me go with the example, for instance, of Scratch. Let me first check the project quota with -g as for group. And let me, for instance, use another of the projects where I belong, Pawsey 0012, and then I need to specify the file system. Let's go for Scratch. I could do the same for software. So this contains some information for Scratch and Pawsey and the project I selected. There is a usage here, 18 megabytes. The limit here is 2 petabytes. And there is 18 files, but the quota on file count is actually per user. So when you have a look with the per project with -g, the key information is actually the one on size, 18 megabytes out of 2 petabytes. Let me show you how to get the information actually in the file count. It's the same command, LFS quota-h. Now it's -u as for user. And I want to do it for my user. The user variable is quite handy. It gives my username. And then again, Scratch. And here the key information for my username on Scratch is on the file count. So I'm currently storing about 3,000 files on Scratch out of my 2 million file limits. And that's how you get, this is basically the same information that you can get from Pawsey account balance, but it can be handy if you want to dig further with all of the details. Now let me go back to these slides, see if I missed anything important. Yes, so the best practice here is to every now and then monitor the usage in a proactive way. And that's because if you hit on the quota limits, what can happen is that you run a workflow and no further files can be written on disk. So you're just wasting your CPU time, because once you pass the quota, you can't write any more files. So it's important to keep an eye on your quota usage. And these are just the outputs of what I just showed you on my terminal, just for the record, for the YouTube viewers. In summary, in this module, we learned a bit about what a file system is, what file system we have available at Pawsey. We learned how to monitor the file system quotas that are in place. And then I shared with you some best and best practices around file system usage. So at Pawsey, we have a support portal online, which can be quite useful for researchers using the facility. There is a user support documentation, which covers a lot of topics in quite great detail. We also have a user support portal for those of you that are in trouble and need and are seeking direct help from the Pawsey staff. And if you want to stay up to date with news and events, there is you can subscribe to the Pawsey Friends newsletter. So this module is over. Thank you, and the session is open for questions.